Yes, dear students, listen. So now in the today's class we'll discuss about that level 3 questions objective. Okay, let's see the first one. Already this model in level 2 we did. See what they gave. Some radius of cation and anions they given. So according to that, it belongs to, we have to find the given compound coordination number we need to find out. So for this case, radius ratio of cation and anion value and coordination number we need to remember. Let's see that radius ratio is less than 0.155, then its coordination number is 2, is in between 0.155 to 0.225, its coordination number is 3, and 0.225 to 0.414, its coordination number is 4, and the radius ratio is in between 0.414 to 0.732, its coordination number is 6, and 0.732 to 0.99, its coordination number is 8, more than 0.99, its coordination number is 12. Already in the last class we have discussed this. Now we have to find out the first one, MgO, magnesium oxide, Mg plus 2 and O minus 2. So the cation is magnesium ion, anion is oxygen. The radius ratio of cation and anion of magnesium oxide is equal to, what is the value? Radius of magnesium is 65 they gave, and radius of oxide ion is 140. So 60 by 140 is equal to how much? Is equal to approximately 0.464. So 0.464 is nothing but, in this coordination number is 6. So magnesium oxide coordination number is 6. In the same way, the remaining also we need to solve. Let's see the B, what they gave. Boric anhydride, B2O3. The B2O3, boron is positive charge, oxygen is negative charge. Its radius ratio of cation and anion is equal to, boron radius of boron is equals to 27 by oxygen 140, oxide ion is equal to 0.192. 0.192 is nothing but in between the 0.115 to 0.225. Then the coordination number is 3. Coordination number is 3. Let's see that. Third one, magnesium sulfide, MgS. Magnesium sulfide, in that magnesium is positive charge, sulfide is negative charge. The radius of magnesium by radius of sulfide ion is equal to magnesium 65 by sulfide ion is 184. Then we'll get this value is in between 0.353. 0.353 means in between 0.225 to 0.414. Then the coordination number is 4. Let's see the next fourth one, cesium chloride. Cesium chloride, the cesium plus and Cl minus is the radius ratio of cation by anion is equal to cesium 169 by chloride ion is 181. Then we'll get 0.93. 0.93 is nothing but in between the 0.73 to 0.99. Then the coordination number is 6. Sorry, coordination number is 8. So according that, the correct option is second one. Means the first one is R, means magnesium oxide coordination number is 6. Okay, and B2O3 the coordination number is 3. And magnesium sulfide MgS the coordination number is 4. Okay, next cesium chloride coordination number is 8. Okay, this is the correct matching. So the main thing is here we have to remember that radius ratio values in the range values and coordination number that we have to keep it in our mind. According to that, the given compound radius of cation and radius of anion they gave. So just we have to find out the ratio. Then that ratio is in between that, either in the theoretical data. From the theoretical data, we have to identify whether it is in which range. According to that, we have to find out coordination number. Let's see that. Next, fourth question. This is the third question. Next, fourth question. A solid AB has cesium chloride structure. The edge length 4.04 angstroms. The distance of closest approach, that is nothing but nearest neighboring distance. Nearest neighboring distance. D is always is equal to 2R. That value we have to find out. In BCC, cesium chloride has BCC crystal structure. In BCC crystal structure, 4R is equals to root 3A. Then 2R is equals to root 3A by 2. Therefore, D is equals to 2R is equals to root 3A by 2. Then root 3 value is 1.732 and A value is 4.04 angstroms. Edge length is 4.04 angstroms by 2. This is on simplification. We'll get approximately 3.49 angstroms. 3.49 angstroms is nothing but 3.5 angstroms. So the correct answer is third one. So in this question, how to solve in this question? Cesium chloride. So they are not mentioned. The cesium chloride, we have to remember theoretically, cesium chloride has BCC crystal structure. Cesium chloride has a BCC. In BCC crystal structure, the relation 4R is equal to root 3A. Means root 3A is nothing but body diagonal. Body diagonal length, theoretically it is equal to 4R, and in terms of edge length is equal to root 3A. But nearest neighboring distance or closest approach value is equal to D is equal to 2R. The 2R is equal to root 3A by 2. Root 3 into A by 2. Just that value I calculated. Just we have to calculate. Then we'll get the closest approach is 3.5 angstroms. Okay, let's see next, fifth question. Okay, listen dear students, VBT theory. VBT, valency bond theory. So regarding that VBT theory, which is not correct statement, means it is very clear. It does not explain the metallic cluster. Metallic cluster means brightness of metals. But this VBT theory is based on resonance. They proposed a resonance concept. Resonance, according to the resonance, the molecules are two types. One is polar covalent bonds. The second one is non-polar covalent bonds. Non-polar covalent bonds. And it mainly explains that conductivity properties in metals. Explains conductivity properties in metals in solid state, but does not explain in solution state. Okay, to explain that conductivity properties in metals, they proposed two types of. One is polar resonance structure, the second one is non-polar resonance structures they proposed. For example, lithium, you take lithium metals. Among these lithium, they proposed lithium is generally one bond will forms, but here two bonds are present means it having positive charge, then it has a negative charge is present. Sorry, here one unit negative charge is present because of more bonding capacity. Automatically here no bonds is present means positive charge. Positive and negative charge is present means it is polar resonance structures. Polar resonance structures. Immediately what happens, this bond will be uh, exchanged. Now it has positive charge and this lithium has negative charge. Like that we'll get structures. Those structures are called polar resonance structures. They are having polar covalent bond. Okay, the next one is non-polar in lithium metal only. Let's see. Here lithium and the lithium there is does not having any charge. This bond will be shifting from here to here. Then we'll get one more structure and the lithium. So this is called non-polar resonance structures. Okay. So this is about a VBT theory. So in that incorrect option is fourth option. In that fifth question, the incorrect option is fourth option is incorrect. Let's see the next sixth question. In the sixth question, they given one structure. See, this is atoms. These atoms are present at corners and face center. Face center and corners. These are the voids. This S is void. Void. So it is belongs to what type of void they're asked. Either it is octahedral void or tetrahedral void. It is octahedral void. We know that octahedral voids. Octahedral void. Octahedral void present at body center and edge centers. Okay, see if you observe that S here in this here S atoms sorry S is present at edge center. Therefore it is octahedral void. Octahedral void, and it is FCC in FCC crystal structure. See, the all atoms are present at corners and face centers, and tetrahedral voids TV means tetrahedral voids, they are located at corners only. So here the void is located at edge center. That's why it is a edge center. That's why it is octahedral void. Okay, let's see the next seventh question. The seventh question, what they are asked. Let's see, SiO2, silicon dioxide. SiO2 has been crystalline as well as amorphous. The following properties. One is crystalline property. SiO4 has a tetrahedral randomly joined, giving rise to polymeric chains, three-dimensional sheets, and they have high and sharp melting points. Like three statements they given. among the three statements 1, 2, 3 are not matching to amorphous solids, So amorphous 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 solids means their structure is not crystalline structure. So the first statement is not correct. Not correct. Because amorphous crystals, they doesn't have crystalline structure. Amorphous solids, they doesn't have crystalline structure. And they doesn't contain sharp melting and boiling points. Or doesn't contain sharp melting points and doesn't have high melting points. High melting points and sharp melting points characteristic is related to crystalline solids but not amorphous solids. So third one is also not. So the option is third answer. First and third statements are not belongs to amorphous solids. Amorphous solids. Okay. Let's see next question. Eighth question. Let's see, ma. NaCl. NaCl is doped with, doping means addition of impurities, doped with 10 to the power of minus 3 mole of strontium chloride. So in which strontium ion. So strontium chloride is nothing but Sr plus 2Cl minus 1 strontium ion. 1 Sr plus 2 ion can replace 2 Na plus ions and 1 Sr plus 2 ion occupies one position of Na plus ion. So how many number of cation vacancies present in 1 per mole of NaCl they asked. See, according to that, number of cation vacancies, number of Na plus vacancies is equals to number of Sr plus 2 ions. Number of Sr plus 2 ions. Number of Sr plus 2 ions is nothing but number of moles into Avogadro number. Number of moles of Sr plus 2 ions, how many are there? 10 to the power of minus 3 into Avogadro number 6.02 into 10 to the power of 23. Then 10 to the power of minus 3 and 10 to the power of 23, there 3 will cancel, then the resultant value is 6.02 into 10 to the power of 20. 10 to the power of 20. So the correct answer is 6.023 into 10 to the power of 20 Sr plus 2 ions are present. In that Sr plus 2 ions can replace 2 times of Na plus ions. In that half of Na plus ions are occupied by Sr 2 plus ions, the remaining are vacancies. So that's why number of Na plus ions vacancies is equal to number of Sr plus 2 ions. That is equal to 6.02 into 10 to the power of 20. Let's see ninth question. Lithium selenide can be described as cubic closed packing structure, CCP. CCP or is also called as FCC crystalline structure is present. Okay, arrange that selenide ions with lithium ions, all of tetrahedral holds. See, selenide ions Sc has FCC structure, then number of selenium atoms is equal to Z is equal to 4. Next, lithium ions. The lithium ions all are present at tetrahedral whites. Number of lithium ions is equals to 2 into Z is equals to number of tetrahedral whites. Okay, 2 into Z, 4 is equal to 8. Then lithium is to selenide, Se is equals to 8 is to 4 is the simplest ratio is 2 is to 1. Therefore, the formula is equal to Li to Se. Li to Se. So the first option is correct. Next, let's see the 10th question is very, very important and easy also. See in the 10th question, the packing fraction of NaCl as long as that one phase diagonal is removed. So NaCl, first we'll think about that NaCl structure. One NaCl unit cell contains 27 ions are present. 27 ions present. Okay, 27 ions present in which in which 14 chloride ions are present and 13 Na plus ions are present. These 14 chloride ions means what ma? There are 14 chloride ions present, 8 at corners, 8 Cl minus ions at corners and the remaining 6 chloride ions at face centers. Okay, so 13 Na plus ions are present. These 13 Na plus ions are present at edge centers. 13 Na plus ions are present. One Na plus ion is present at body center and remaining 12 ions at edge centers. Okay, it is very clear. Now one phase diagonal is missed. Let's see, before discussing that packing efficiency, what is the volume of NaCl unit cell? See, NaCl unit cell has FCC like structure. Z is equal to 4, means 4 NaCl molecules are present. That is 4 NaCl molecules are present and in NaCl edge length A is equals to 2 into radius of cation plus radius of anion. Then the volume of NaCl is equals to A cube is equals to 2 cube, means 8 into radius of cation plus radius of anion whole cube. Now this is the volume of NaCl. And what is the volume of NaCl atoms occupied in FCC crystal structure, that we have to calculate. So the volume of chloride ions is equals to the volume of chloride ions, means the chloride ions are present at corners and 6 phase centers are present. Then number of chloride ions into 4/3 pi r cube, because the atoms their volume is equal to 4/3 pi r cube. Number of chloride, one phase diagonal is missed. One phase diagonal means this is one phase diagonal. In this one phase diagonal, here middle one chloride ion, and here at corners two chloride ions are present. One phase diagonal is missed. Means that is two corner chloride ions and one face center chloride ion is missed. So therefore volume of Cl minus is equal to volume of Cl minus is equal to total 8 chloride ions. Out of that 8, 6 only present. 6 into its contribution is equal to 1 by 8. 1 by 8 plus total 6 phase centers, 5 only present. 5 and its contribution is equal to 1 by 2 brackets 4 by 3 pi r cube. Okay, 4 by 3 pi r cube, because the radius of anion minus symbol we have to use. If you simplify that, we'll get 13 by 3 pi r minus cube. The same way, volume of Na plus ions is equals to one sodium atom is present at body diagonal, means it is 1. The remaining 12 are edge centers. Each edge center, its contribution is equal to 1 by 4 into 4/3 pi r cube of plus, then is equal to, on simplification we'll get 16 by 3 pi r cube plus. So the total volume of chloride ions and Na plus ions, then packing efficiency is equal to packing efficiency is volume occupied by the Na plus and Cl minus ions. How much ma? That is 13 by 3 pi r minus whole cube plus 16 by 3 pi r plus cation whole cube brackets whole by the radius of volume of unit cell. Volume of unit cell is nothing but 8 into r plus r minus whole cube. The correct answer is first one. See, it is very simple ma. In NaCl packing efficiency, they are asked for calculating the packing efficiency of NaCl. One important concept also they are introduced, that is one phase diagonal is missed. Total out of 14 chloride ions, 8 chloride ions at corners and 6 chloride ions at face centers. There are 2 chloride ions at corners and 1 chloride ion at face center is missed. That's why the total number of chloride ions is equal to 6 into 1 by 8 plus 5 into 1 by 2 into 4/3 pi r cube. That is the volume of chloride ion. Then that is equal to, if you simplified, means 6 by 8 plus 5 by 2 into 4 by 3 pi r cube. This is on simplification, we will get 13 by 3 pi r minus whole cube. And the packing efficiency of Na plus ions are not missed. The total, how many Na plus ions are present? 4 Na plus ions are present. 1 plus 12 into 1 by 4 is nothing but 12 1 ja 12 3 ja, 3 times it will cancel. 1 plus 3 is nothing but 4. 4 into 4 by 3 pi r cube is nothing but 16. 16 by 3 pi r plus whole cube. That's why the total volume of Na plus and Cl minus is equal to 13 by 3 pi r minus whole cube plus 16 by 3 pi r whole cube whole by the volume of unit cell. Volume of NaCl unit cell, that is 8 into r plus r minus whole cube. So the first option is correct. Okay, next let's see that 11th question. Let's see 11th question, which is true. This 11th question is theoretical approach ma roach is salt. Roach is salt. Rochelle salt is nothing but sodium potassium tartrate. This sodium potassium tartrate is known as Rochelle salt. It is ferroelectrolytic solid. Ferroelectric solid. Ferroelectric solid means its net dipole moment nu not equal to 0. And lead zirconium nitrate Pb ZrO3. This is lead zirconium nitrate is anti-ferro electrolytic solid. So we have to remember this concept, theoretical concept. So Roche salt is a ferroelectric solid. Its net dipole moment not equal to 0, and lead zirconate PbZrO3 is antiferro electrolytic solid. Its net dipole moment nu is equal to 0. Okay. So according to that first statement, we have to remember Roche salt is, sorry, not first statement ma. That is here options they are not given properly. So that sorry, first one Roche salt is ferroelectrolytic and lead zirconate is antiferroelectrolyte. So the first option is correct. Next 12th question, let's see. The edge length of cubic unit cell is 400 picometers. Its face diagonal would be cubic unit cell. Edge length of cubic unit cell means CCP or FCC. Face diagonal is equal to root 2a. Okay, so A value they given, A is 400 picometers, root 2 into 400, then is nothing but root 2 value is 1.414 into 400 is equal to approximately 566 picometers or 565.6 picometers will comes, is nothing but 566 picometers. So the correct answer is third option is correct. Okay, let's see that 13th question. The body diagonal in a cube is 866 picometers. Its edge length they are asked. Body diagonal. So in BCC, body diagonal is equals to root 3a is equals to body diagonal is equals to root 3a. Okay, 4r is equal to root 3a theoretically. In that edge length they are asked. So root 3a is equal to 866 picometers they get. Then a is equals to 866 by root 3. 866 by root 3. Root 3 value 1.732. 866 by 1.732 is equal to, is on simplification we will get 500 picometers. So the correct answer is third one, 500 picometers. Let's see 14th question. The radius of Na plus and Cl minus, then the edge length of NaCl would be there asked. Already we know that in NaCl, the edge length A is equals to 2 into radius of Na plus radius of Cl minus or radius of anion. So what they asked, the edge length of NaCl they asked. So the edge length is equals to 2 into radius of Na plus how much they gave? 95 you substitute. Then Cl minus is equals to 181. Then this is on simplification 2 into 276 is equals to 552 picometers. Okay, direct. So in NaCl, edge length is equals to 2 into radius of Na plus Cl minus. That is important formula. So next 15th question. Let's see the 15th question. A metal crystallizes in two cubic phases FCC and BCC. The unit cell lengths are 3.5 and 3.0 angstrom respectively. The density of FCC and BCC, the density ratio they are asked. So for this case, density D is equals to Z into M by A cube into Na. Okay. So Z is same for density of here M is same, means mass of element is same, and Na is same, Avogadro number is same, Z and A cube, edge lengths are changing, the density, a metal crystallizes in two cubic phases FCC and BCC, the radius ratio of FCC to BCC, the density ratio of FCC and BCC they are asked, density ratio of FCC by density ratio of BCC, so is equals to this M value will cancel, Z by A cube of FCC into A cube by Z of BCC will comes. Then for FCC Z is equals to 4 and density edge length is equal to how much they gave for FCC edge length is 3.05 angstroms and BCC is equals to 3, then 3.5 whole cube into 3.0 whole cube by Z value for BCC is 2.